Welcome to the Introduction to CAD and CAE. In Simulation Thermal Project 1, you create a thermal simulation on a multi-layered pipe. After completing this lesson, you will be able to create a thermal simulation for a multi-layered pipe, apply materials to the 3 layers of the pipe, apply thermal loads, perform a simulation based on the settings, then review the results and create a report. I've opened up the supplied file. This is a pipe with 3 layers, and you can see that highlighted in the model. I'm going to go from Model to Simulation, click on Thermal, then click OK. First thing I'm going to do is change the material. There are 3 bodies, starting with the inner pipe. That's going to be copper, in this case copper wrought. So it's a processed copper, in this case tubing. The second material for the middle pipe is going to be polyurethane foam. And then for the third one, ABS plastic for the outer pipe. Let's turn off the visibility. We're going to hide 2 of the pipes. Go to Load. Select those 3 faces. For type, I'm going to select Radiation. And for temperature, it's going to be 100 degrees. Click OK. Now show the other 2 bodies. Back to Load. Select the 3 outside faces. Again, Radiation. And the temperature value is going to be 24. Go to Contact, Automatic Contacts, and that gap of 0.1 millimeters is fine. If you want to manage the contacts, back to Contact, Manage Contacts, and here you can see a list of all the contacts that were automatically created. Right-click on Mesh and generate the mesh. Once the mesh is generated, we'll review that to see if the size of the mesh is acceptable. Click on Cancel, and it's not, so we're going to have to Manage, Settings, and in Settings select Mesh, and under Model Base Size, it's anywhere from 1 to 10%. I'm going to 3%. In Adaptive Mesh Refinement, change it from None to High. And change the baseline accuracy to Temperature. Click OK. And generate the mesh again to see those changes. So expect the mesh to be much smaller. Click on Cancel, and that looks better. If we review the end, we can see that the mesh size on the inner pipe, that copper pipe, is also acceptable. Through the foam, and then the ABS plastic. Back to the home view, do a pre-check. We have all the information, so I can click Solve, and I'm going to do that locally. So from Job Status, we see that the local solve has started. The results are now posted. The solve has been successful. We see the temperature range from 27 minimum to just over 100 max. Now we want to analyze. We see that color range starting with the 100 degrees in the middle, all the way out to the ABS plastic. We have a number of tools that we can use. Here we see the min-max. And if we go to Inspect, we have surface probes. So clicking on surface probe, we just run that probe over the surface to check the temperature. We have a point probe. So you can click, then drag that through the multi-layered pipe. You can also create a slice plane. So just click on the surface, and once you've done that, you can drag that plane through the part. I just want to check that bottom left-hand corner. So I'm combining the slice plane. Back to Inspect, a surface probe. And you just run that probe through the parts, and you can see the range of temperatures changing from the warm, from the 100 degrees on the inside, out to the plastic. Similarly on the top of the pipe. Click OK. Back to the home view, and just undo to get rid of that plane. Delete all the probes. And from here, I can go to Material and determine whether these materials are suitable. Was that range of temperatures acceptable? Material is one of the easiest ways to change that. Any of these three could be changed, or the dimensions could be changed. I can now go to Manage and create a report, and that report can be shared with other members of the design team.